astronomer at the SETI Institute. That's SETI. Almost my name, but that's coincidence. SETI is an acronym, and it stands for the Search for Extraterrestrial Intelligence. In other words, not just life in space, but life that's as clever as you are, or maybe even more so, not to take anything away from your cleverness. So today we're going to talk about a related topic on that score, and in particular, planets. Joining me as my co-host is the very funny Chuck Nice.
Hey, man. How are you, Seth?
I'm just fine, Chuck.
Glad to have you here.
Well,
I'm very interested. The search for extraterrestrial intelligence.
Right.
Because the question is, do we even qualify as that?
Yeah, that's a legitimate question. People ask, is there intelligence inside the Beltway or whatever?
Right.
And we have an operational definition of intelligence, just,
Oh, really?
Yeah, it's simple.
Excellent.
Can you build a radio transmitter? That's
there
it.
you have it.
Can you build a radio transmitter? You're intelligent.
So I'm not intelligent.
Well, listen, nobody at any of the parties I go to is able to do that either.
There you go.
So, and our guest is Jason Wright, and he's an associate professor of astronomy, a member of the Center for Exoplanets and Habitable Worlds, and he works at Penn State University in State College,
Seth.
Pennsylvania. Hey, Jason, how you doing?
I'm doing really well.
Listen,
I'm actually coming to you from Aspen, Colorado, of all places at the moment.
Really? Well, that's just a terrible place. I don't know.
Yeah, I know. It's rough.
Why you'd want to be up there.
No, it just sucks to be you, right?
Exactly.
Well, what we want to know from you is what's the status of planets, not around our own sun, but around other suns. And, one of the big news items recently was the discovery of a planet that may end up being the closest planet to us of any of them that aren't in our own solar system, Proxima b. Tell me a little bit about Proxima b.
Right, that is big news. So there's no maybe about it. This planet is definitely the closest planet to the sun that's not orbiting the sun. So the star is called Proxima. We used to always call it Proxima Centauri, which is just Latin for the closest thing in the constellation of the Centaur. But now we know that it's actually the very closest star to the sun anywhere. So its planets really are the closest. So we've been finding planets around other stars in the galaxy for a little over 20 years now. And thanks to space missions like the Kepler Space Telescope, we now know of thousands of planets in the galaxy. And this one, though, is different. It's special because it's really our neighbor. And so we're going to be studying this one in particular because it's right there forever, basically. And we're going to be wondering about it and how to get there and what we can learn about it.
Well, you say it's the closest one. I mean, maybe we ought to give them a number for that. How far away is it?
So stars are really, really far away, to get technical about it. This one being close is a little over 4 light years away. So if you could ride on a light beam, then it would only take you 4 years to get there. So in cosmic terms, they're our neighbors. They're right next door.
Yeah, but I can't ride a light beam.
Yeah, I would love to ride on a light beam, as a matter of fact. That's going to be the name of my next album, Riding on a Light Beam with Chuck Nice.
That's nice.
So give us an idea of 4 light years. Let's break that down into human terms. How long would it take us to get there?
Well, if we got our best rockets, launched a probe into interstellar space, and we've done this before, so we know we could do that. Let's see, it would take something like 100,000 years to get there, maybe tens of thousands of years if we went really fast.
Yeah, I figure about 100,000 is right. I mean, that's a long time to be eating peanuts off your lap in the middle seat, right? So 75,000 years to get there. Yeah, but it isn't to say that you couldn't get there faster. I mean, if you don't want to go yourself and you just want to send some sort of object, maybe the size of a silver dollar or something like that, to Proxima,
right.
You could do that faster, couldn't you?
Well, in principle, right. I mean, this used to be all science fiction, but, recently people have thought hard about this. There's a project called Breakthrough Starshot, which is trying to figure out how to do exactly that. So there's this old idea that if you gave a spaceship a sail, a light sail, so just like a big parachute or something, and then you shot a really powerful laser beam at that parachute, you could accelerate something really fast. And it takes a really powerful laser beam to launch something that could have a person in it. But if you only wanted to launch like a tiny little microchip or something like that, something that weighs less than a raisin, then you would only need a super-powered laser about a square kilometer across.
Well, that's a very modest requirement, isn't
it?
Yeah.
I know.
Yeah.
Okay, well, let's get back to those planets if we could, Jason, because, how many planets out there are not just, kind of worthless planets like Neptune, Uranus, those guys, but, might be the kind you'd want to build condos on, or, the kind where you might have oceans, atmospheres, that kind of thing.
Beachfront property is what we're talking about here, Jason.
Right. You want to see water on that thing. Someplace
That's right.
we would want to visit. Well, let's see. There's about 100 billion stars in the Milky Way galaxy, and we now know that most or all of them have planets. Mm-hmm. And so right away we know that we've got many hundreds of billions of planets in the Milky Way galaxy. And some fraction of them, like 10 or 20%, probably have about the temperature that you would need for liquid water. And so we're talking about tens of billions of planets in the Milky Way that could.
Wow.
And we like those planets that might have liquid water because we want to study them and figure out if they do have liquid water or whatever. So yeah, there's a lot of property out there to be claimed.
Look at that.
So I mean, what you're saying, if there are tens of billions of planets that are sort of like the Earth, the possibility that this is the only place where anything interesting is happening, if you think anything interesting is happening here,
right?
Yeah, right. I mean, that would make us pretty special, wouldn't it?
If they were right, if none of them had life like life on Earth, yeah, that would make Earth, fantastically unique. One in 10 billion or something like that. That would be maybe very surprising.
Yeah, but is it possible too? I mean, when you think about, if you were just to play Earth out to its logical conclusion, which is the sun will expand and burn us all to a crisp. Is it possible that has already happened? So there's been life, but it's expired because, of course, that's what all life does at some point. So is how would we be able to find that signature, or is that if the idea is to find life first and then you can draw those conclusions?
Well, it's true. There's got to be a lot of planets out there that used to be able to have liquid water on it. And by the way, the term we use, we say that the planet's in what's called the habitable zone.
Right.
That just means it's far enough from its star so that it's not boiling all the water away. But it's close enough to the star that it's not just an ice ball. So when planets are in that habitable zone, that's where we think we'd see this liquid water. And so certainly there are planets that used to be in habitable zones of their stars, but something happened, like the star got big and blew up or burned out, or one of the things stars do, or something might have happened to the planet in its orbit. So when we give that count, we're talking about the number of planets that are in their habitable zones today. But yeah, the history of the galaxy is 10 billion years, and so there's probably a lot of formerly habitable planets out there.
Yeah, it sounds to me like Chuck is more interested in life that's deceased than in the country. I mean, it's like going to New Jersey and looking for fossils instead of looking for New Jerseyites, right?
Exactly.
Yeah, there are plenty of fossils.
But
yeah, and some of them are actually New Jerseyites.
Yeah,
okay.
Most of them have been buried by irreputable forces, I'll just say.
Jason, I've got to ask you, because you're really responsible for this idea being promulgated about a star that has the lovely name KI6 8462852. All right, never mind the name.
Say that name again, please.
KIC 8462852, but I may have gotten it wrong.
How can you remember that, Seth? I can never remember that.
It just falls off the tongue, actually, I find. But I call it Bob, whatever.
That's very cool.
So this is a star. I mean, it's not very close to us, but it's very unusual. And there was really an interesting find about it, but you can tell me about that.
Sure. Well, the Kepler spacecraft was looking for planets around other stars. And to do that, it looked at 100,000 stars. And most of these aren't nearby. They're not like Proxima, just 4 light years away or something. They're more like 400 light years away. And it was watching their brightnesses extremely carefully, just in case a planet, maybe like Earth, passed in front as it went around the star, passed in front of the star and made it a little bit dimmer. And so it found thousands of planets like that. It also found lots of stars misbehaving, getting brighter and dimmer for other reasons. But there was one that was just totally unlike all the other. It started to get dimmer, as if there was a planet going in front of it or something. But then instead of getting just maybe 1% dimmer, because there's a planet like Jupiter around it, it just kept getting dimmer. Oh, and over the course of days, it got like 20% dimmer than it had ever been before. And then all of a sudden, over a few more days, it got bright again. It went back to normal. And stuff like this kept happening. It kept having these strange dimming events as if very large amounts of stuff was between us and the star. This stuff has to be much bigger than something like Jupiter. And whatever it wasn't round like a planet or like another star. And so it just had all the astronomers completely baffled about what was going on.
Well, we don't have too much time, but tell me, what are the possibilities? I mean, a star getting dim like that, it's unprecedented. Could it be alien handiwork?
So, yeah, there's a lot of possibilities. We've been scratching our heads looking for lots of natural explanations. But one thing that I noticed is that there was a guy named Luke Arnold who published a paper before Kepler launched. And he said, hey, if there are advanced civilizations, they might build giant things in space, maybe to collect lots of energy, like solar panels or something. If that's true, then those pass in front of the star. Kepler would see that happen, and it wouldn't look like a planet. It would look like something we totally didn't understand. So when this star was discovered, I said, hey, this guy Luke Arnold, he said we might see this, and if we do, that we should be on the lookout. It could be solar panels. So could be. We're not out of all of our other ideas, but that one's definitely out there now.
Okay, I got to ask you, this is just the last question, really quick now, Jason. If you're sitting in the local diner there in State College, Pennsylvania, and the guy next to you says, okay, how much are you willing to bet that what we're seeing going on here is the result of a giant alien astroengineering project, what do you say?
Well, what odds are you giving me?
No,
not very much. We see weird things in space all the time. We can talk about other bizarre signals that have come from space and turned out to be not aliens, but something really new and amazing and interesting in and of itself. So I think we've almost certainly found a new weird kind of way stars can get dimmer that we haven't seen before. Mm-hmm. But I don't know how to put odds on aliens. I presume it's very low.
Well, Jason Wright, we'll be getting back to you, but now it's time to go to Chuck and the Cosmic Queries. These have been culled from the best questions on the internet about this subject and maybe others.
Yes, exactly. Our listeners are extremely curious as a lot, and they have from Facebook and Twitter and every station where you find Star Talk. They have sent us some queries for you guys to tackle. So you don't know what they are, but it doesn't make a difference. It's not about stumping you. It's just about if there is an answer, I'm sure you'll have it.
I'm glad you said that.
Yeah. So let's jump right into it. Let's start off with a Patreon patron question, and Patreon is a place where people support Star Talk and monetarily. And if they do so, we give them first crack at asking us a cosmic query, just a little perk of buying our love and affection. So this is from Keela Silvis from Patreon, and she says, "I'm Keela Silvis from Minnesota, and my aunt, Dr. Patty Boyd from Goddard, helped me with this particular question for exoplanets." Do you guys know Dr. Patty Boyd, either one of you, gentlemen?
I don't think so.
No?
Well, yeah, she may be working under a pseudonym.
Is it a pseudonym? Yes, exactly. Yes, it's that's her stripper name, yeah. Dr. Patty Boyd. She says, besides radio waves, what signs is humanity giving off to other stars that Earth possesses intelligent life? So aside from the actual signals that we are shooting out into space, is there any other indication from somebody who's looking at us from 4 light years away to say, wow, there might be some intelligent life on this little rock from the sun? I
have to say it hasn't impressed them enough for them to send their interstellar battle wagons to Earth, so there's at least that. I'll let Jason start. What do you think is the answer to that, Jason?
Well, yeah, there's a few ways that you might notice that we were here. One of my favorites is that our large telescopes often shoot big laser beams into space to try and correct for the Earth's atmosphere. We create little artificial stars in our atmosphere and then deform the mirrors of our telescopes to compensate for the blurring effects of the atmosphere. So what that means is we're always shooting these lasers off into space. And so if we shot one at one of, another planet, they might notice the laser. It's pretty weak, but it's conceivable.
But it's only a couple of directions, right? They have to be in the right place.
Yeah. They'd have to be right along. We'd have to be intentionally pointing our telescope at them.
So that
presumably for some other reason.
That would be one way. That would be kind of like the old movies where the person would use a mirror.
Yeah,
they're lost at sea, and the plane says, What's that down there? I think I see something.
It was always cowboys trying to signal that the Indians were afoot. That's what I saw.
Yeah.
Although, that was back before they invented sound.
In movies, when you're standing there and suddenly that little laser beam appears on your chest, it's usually not a good sign. So maybe we shouldn't be doing that.
Well, I'll tell you, that's one way. There are other things, Chuck. I mean,
Definitely.
for example, if you use hairspray, it doesn't look like you use hairspray, but if you wouldn't...
I use mousse.
Okay.
Anyone knows me?
Yeah, well, in the old days, hairspray had these chlorofluorocarbons, and that kind of changed the contents of the atmosphere, right? You remember the ozone hole and all that stuff.
Big hole in the ozone.
If they had a big enough telescope, it had to be a really big telescope, but maybe they could find that in the atmosphere. Hey, what do you think, Zork? That doesn't look natural, so maybe that would be a thing. And, of course, if they had a really big telescope, maybe you're talking about telescopes the size of downtown Baltimore or something, if you had a telescope really big, maybe you could see things like freeway interchanges and so forth, or... And you can work this out, actually. The lights from New York City. You could pick up that light. You'd see, gee, it's awfully close to this. It's a sodium-based light, right? All that orange light.
Right.
We're getting rid of those now, but for a long time. And maybe you could do that. It would take really big instruments. The easiest thing, pick up the radars, the television, the FM radio.
So really, it's more the signals than anything else.
I think so. I think that's a point, because that means that since we've only been doing that since the Second World War, really,
right?
Probably nobody knows we're here. So those people who feel they're being abducted, you got to ask, how come they came now?
Mm-hmm. Right.
Yeah.
So now, in addition to that, does that mean that the signals that we have, however weak, like our just regular television and our regular radio, does that escape and go out as well? I mean, would somebody, let's say, if they had the right listening equipment, be able to pick up a broadcast from 1930? It's just like, good evening, ladies and gentlemen, on Ships at Sea. Would they pick that up as well?
Well, I don't know how they'd feel about the content, but they wouldn't actually be able to pick it up, because AM radio is refracted by the ionosphere. That sounds kind of techie, but what it means is it bounces around the Earth. In fact, that's why you can pick up a Chicago station here on the East Coast or whatever. So it has advantages, but it means that all those early radio signals didn't make it. Do we have a really quick question?
Okay, let's get something very, very quick. Well, I'll give you the question, and then we'll maybe take a break, and we'll make it a cliffhanger. Okay, well, cliffhanger. All right, this is from Nicholas Loving on Facebook. Are there any types of planets that have been theorized to exist but haven't been observed yet?
More or less, Jason T. Wright.
More or less. Aspen, Colorado.
Well, he's on the same planet. All right.
Exactly.
You were just about to throw a cosmic query at us, so let's go back to that.
So Nicholas Loving, right before we had to take a brief respite, said to us via Facebook, are there any types of planets that have been theorized to exist, but yet haven't been discovered or observed? If so, can you provide some examples? It's actually a cool question.
It is. Yeah, cubicle planets or something. All right. Jason, that's a tough one, actually, I think.
It is. Well, we find these planets that are about the mass, about the radius of Earth, but we don't know if they have liquid water on them. So I think that's the easy one. We'd like to really find one that's like Earth with liquid water, a nice atmosphere like ours. But more exotic things, sometimes you see in science fiction or something like that there might be a moon of a planet, a moon of another planet, like something like Jupiter, a moon like Earth. And so we haven't actually found any planet-sized moons around bigger planets yet. And that's something that people are looking for, and that would be really exciting to find. We haven't found any binary planets, so two planets orbiting each other. That's been theorized. It could happen, but we haven't seen any of those. And then there's also ways that you can put more than one planet in the same orbit. So they have the same time to go around the sun. They're just in different parts of the orbit. And that would also be really neat to find. So those are my top at the top of my wish list.
Let me just reverse that very briefly, because one of the most common sorts of planets that we are finding are what are called super Earths. It sounds like they wear capes. Super Earths. But we don't have one in our own solar system. There are no super Earths here. We have ordinary Earths.
Yeah.
What's a super Earth, and why is it so new? And why are they so common?
Yeah, well, I'll take it one at a time. So in the solar system, we have what we call the terrestrial planets that are mostly rocks and metals like Mercury, Venus, Earth, and Mars, and they're all pretty close to the sun. And then farther out, we have the giant planets, the gas giants Jupiter and Saturn, and then the ice giants Uranus and Neptune. So we always figured those are the three kinds of planets. And sure enough, we find lots of gas giants. We find lots of things that are presumably ice giants. But it turns out there's an in-between kind of planet that, and we're not really sure, is it a sub-Neptune? Is it just an ice not quite so giant? Or is it a super Earth? Not meaning it's much better than we are, just that it's much larger and more massive than the Earth. And so one of the surprises that's come out of these searches is that there are a lot of them. In fact, there are a lot more super Earth / sub-Neptunes than there are ice giants and gas giants. So one of the most common kinds of planets in the galaxy, we don't have a single example that we know of in the solar system. And interestingly, Proxima b, just next door, is a little more massive than the Earth. So the very closest exoplanet turns out to be exactly one of this class.
Super Earth. All right.
Super Earth.
Yeah.
All right.
Prepare yourself. Okay.
Well, that's a great answer. Let's move on to Benjamin Bottoms, which I just picked his name because his name is Benjamin Bottoms.
Oh.
I don't know why I find that very...
Not Benjamin Buttons.
Yeah, not buttons, but bottoms. And I don't know why I find that so incredibly entertaining. But I just want to keep saying Benjamin Bottoms for some... I'm sorry. I'm so juvenile.
Oh, so what's the bottom line here?
Exactly. Here we go. Benjamin from Facebook says this. I would still love to know what SETI and NASA have been doing about seeing what flora and fauna will adapt and what will change under the effects of hypergravity, including higher masses found with Proxima Centauri and other exoplanets. I hope to do my own research on this, though doing it with minimal resources.
Right.
In other words,
he's no different from us, actually, in that regard, at least. But
so anyway, how would the development of flora and fauna be affected by stronger gravity on exoplanets? Maybe a super Earth. So you got a super.
Well, let me just start. But I obviously turn this to Jason. The gravity of a planet doesn't change very rapidly when you make the planet a little bit bigger, a little bit smaller. Mm-hmm. If I remember my high school physics correctly, I think it scales as the radius, more or less. So, in fact, if all other things being equal, if you had a planet that's 50% larger in diameter than the Earth, and maybe the Proxima b planet is like that, or 20% or something like that, then the gravity, it's a little stronger. And instead of weighing 150 pounds, you'd weigh 230 pounds or something like that. I don't know that would change things terribly much. I mean, the range of weights that we have, even as it is, certainly encompasses those kinds of changes. So hypergravity, I mean, I don't know what you mean by that. 100 times the gravity of Earth, you're not going to find that on a planet, but I think you'd keep low to the ground. Jason, what would you say?
No, I agree with you. We don't expect the gravity to be too much higher. I suppose you could put plants and things in centrifuges and subject them to high G-forces and see how they do. But the topic of how Earth life in particular might adapt to other situations is actually one of considerable research. NASA funds a lot of research into what are called extremophiles. That's Earth life that really thrives or lives at all, in fact, in very extreme environments. So very hot environments, very cold environments, water that's extremely saline, very acidic environments. And the idea is, to what degree can life as we know it exist in environments as we don't know it? Like, could we have algae that live on Mars, for instance? And that's hopefully going to give us an idea of what sorts of planets are amenable to life as we know it, so that we know where to point our telescopes and try and find it.
So what you're saying is having increased gravity may be the least of your problems.
Yes.
Yeah. It may not be attractive, but of course it will be attractive. Chuck, you're on for another question here.
Okay, let's go to John Roberts, who's coming to us from Denver, Colorado. And John says this: of all the known exoplanets that can support life as we know it, how thoroughly are they being observed or listened to for signs of intelligent life?
Yeah. Well, let's start with the observe part, because in general, this may not be known by everybody. We don't actually see these planets. Jason, how carefully are they being observed, man? Maybe you have a secret project here.
No, that's a good point. A lot of the planets that we've discovered, we haven't actually taken a picture that shows a little dot and says, there's the planet next to the star going around. We often infer the planet's existence because as the planet orbits the star, in a small way, the star also kind of orbits the planet. They orbit each other's center of mass, and we can detect that small wobble of the star and say, oh, there must be a planet there. So in those cases, we can't actually study the planet itself at all, and certainly not any planets that are cold enough that they might have liquid water on the surface, might have life. Now, the exception is when one of those planets passes between us and their star, and in that case, we can use the star's light to backlight the planet, and some of the light will pass through this planet's atmosphere, and then we can study what the atmosphere is made of, and that's a subject of intense research. It's something that the new James Webb Space Telescope will do once it's launched to try and do exactly that. But for the moment, we haven't actually identified any planets that have atmospheres like ours that we think do have liquid water on the surface like ours. So we have to find them first. But once we find them and can study them, then absolutely we'll observe them a lot.
Could we find things like maybe some oxygen in their atmosphere and say, I don't know what's there, but there's some plant?
Well, that's right. So there's a lot of talk about what are called biosignatures. So what would you have to see on a planet to know that there's any kind of life on it? And if it's life as we know it, then absolutely. Oxygen would be a great signature that there's some kind of photosynthetic life. Although for almost any biosignature you can think of, there's some clever geochemist that can think of some natural process that would have created it without life. So it's not necessarily going to be a slam dunk.
Yeah. Geochemists, always the haters.
Well, no, they're too clever. By the way, part of that question was, are we actually pointing our radio telescopes in the directions of these worlds to see if we get any signals? And the answer to that is yes. Generally speaking, we do. But, I have to point out the obvious. The Klingons could have pointed their antennas in the direction of Earth for 4.5 billion years and not picked up I Love Lucy, right? So the fact that you don't pick up a signal doesn't mean there isn't anybody at home.
Right. And so, and the other thing is they have to be able to build something that would allow us to pick up a signal, right?
Right.
That's what we're listening for.
Yeah. They must have the technology, as they said about this $6 million guy. Yeah. All right, let's go to another question.
All right, here we go. Matthew Mellerin. Okay, Matthew, I think I got your name right. Matthew Mellerin says this: if an alien signal is detected by SETI, how much time would it take before SETI, as a team, can confidently determine that the signal is legitimate? And sorry, that's from Eric Coronado.
Oh,
sorry.
I guess Matthew wasn't actually.
Matthew, I'm sorry. I'm not going to read your question. So.
You just lost a listener there.
Sorry, Matthew. Right. No, I'm going to get to your question next, Matthew. So that's a great question, though. What is the protocol?
Yeah.
What exactly is the
Well, there is a protocol. Everybody asks about the protocol. It sounds kind of evil to me, frankly, but there is a protocol, and it's like 3 typewritten pages or something. It's just a gentleman's agreement. It has no force of law. Nobody stands behind it. Nobody's going to, the men in black are going to show up and enforce it. They're not going to do that, right? It would be maybe better if they did, because
I'm a little disappointed now.
Yeah, there will be some budget somewhere for this to work, right?
Agent J to show up and give us the scoop.
I keep waiting to see Will Smith walk into the office, but he hasn't done that. No, what it says is this: if you find a signal that looks like it's the real deal, the first thing you do is confirm it to make sure that it's real. And that's, of course, the basis of this question. How long does that take? The second thing you do is you tell everybody. And the third thing you do is you refrain from sending anything back. Hi, we're the Earthlings. Something like that, without sort of international consultation, so nobody feels that that's a bad idea. Okay, that's the protocol. It's apple pie and motherhood. Nobody can argue with that. But, in fact, I can tell you what really happens, because we've had false alarms, and more than one, in which we've gotten a signal in which we thought, well, maybe this is it, right? And so some people are reading the protocol, but it's irrelevant to read that, because what really happens is that as soon as you get a signal, there's no policy of secrecy. Everybody's, tweeting and blogging and whatever, right?
Exactly.
Yeah. And the media are going nuts, and your phone is, melting down, because the media want to know, well, what about that signal?
Right.
And that's what really happens. Now, the amount of time it would take to get to the point where you'd say, okay, it's time for a press conference, all of which is, of course, water under the bridge by that point.
When does Jodie Foster get into this?
Yeah. Well, I wish she would get into it. But, no, it would take, on the order of 5 days a week, something like that, because you would have to get somebody at another radio observatory to check the signal. Because if you were the only one to get it, it could be a Stanford undergraduate prank or something. So you've got to rule that out.
You know how those Stanford undergrads are.
Yeah, well, I pick on them, but they're nearby. Okay.
So basically, the most important thing is confirmation.
Yes,
that's the most important.
Yes, because it's going to be a big story. We know that. We've seen it happen, and because the public is interested, they see aliens every night on television, in the movies, whatever, and they fully expect that they're out there, most of them. So it would be a very big story, and you don't want to say, "Hey, we found them," and then a week later say, "Well, actually, we didn't find them." Right. That would be a bummer.
Never mind. All right, hey, that's pretty cool, Eric. Thanks a lot. Let's now go to Matthew Mellerin, who I said I would get to your, and I will. From Facebook wants to know this. Will there ever be a way to detect exoplanets quickly without the need for long periods of observation? In other words, will there be a kind of like quick and easy snap to it, like, hey, another exoplanet, there we go?
Yeah. Well, they might put Jason out of a job. Jason, what do you think?
Well, normally we have to wait for it to go all the way around the star. So whatever the planet's orbital period is, you want to have 2 or 3 of those. And so if it's a planet like the Earth, that's going to take something like 3 years. But the other way is if you have a really, really good camera, something that can just take a picture of the planet. And then it's just point and click. You point, you take a picture of the star. Oh, look, the dot there, that's the planet. And if you have the right kind of camera, it can tell you right away if it's the planet or not. Now, so that's the dream. It's called coronagraphy. And there are chronographs that exist, and they look for a long time. But if they look at the right star, in a matter of minutes, they know that they've found something that looks like a planet right next to it. So, yeah, hopefully we'll at some point get some space-based coronagraphic telescopes that can just point and click and find them pretty quickly.
But
that
sounds like,
speaking, it'll take a while.
That sounds like Tom Hanks, right? Was it the Right Stuff? Whatever. Tom Hanks puts his thumb up and blocks the moon.
Blocks the moon,
right?
right.
I mean, that's sort of what you're doing. You're trying to block the light from the star because that's drowning out the light from the planet, right?
That's right.
And you just want to hold a nickel in front of the star and see if you can see the planet, kind of thing.
And it's a really hard problem. People talk about trying to, find a firefly next to a searchlight in New York, but you're doing it from Los Angeles.
And for today's show, most importantly, they're planets. All right, let's jump right back into talking about exoplanets, but we go to Chuck for
another cosmic query. Yeah. This one coming from Jason Cook. Jason says this: I've been hearing about the potential planet X that's being hunted. Could be a captured exoplanet. Would this mean that it was a rogue planet, or could it have been caught from Schultz's star? So
Schultz's star?
Schultz's star, yeah.
Yeah, I've never heard Schultz's star, but Schultz has presumably heard about it. Have you heard about Schultz's star, Jason? But you certainly know about Planet 9, but...
Sure, yeah, I haven't heard of Schultz's star. If there is another planet in the solar system, way out in the outer solar system, it's very weakly attached to the solar system. And so in principle, I suppose it could have been captured by the sun, which would make it, a rogue planet, which is one that used to orbit another star, but had some sort of gravitational tussle with another star planet and got ejected and was floating around in space. So I'm not an expert on it, but that sounds like a distant possibility.
Yeah, well, there are probably a lot of rogue planets out there, right? I mean, people have done sort of theoretical modeling of all this, so they do it in the computer. And you build a whole bunch of planets, and maybe a third or a half or something like that of them get kicked out of the nest in the very early days, and they just wander in space. So, you never see them again. Maybe this was one. Yeah.
So it's a possibility.
Possibility.
So the answer to your question is yes. Okay.
Concise.
Here we go. This one from Tom Donovan says this: of all the stars we can see with the naked eye, which are stars in our galaxy and which are galaxies outside of the Milky Way? What percentage of the stars we see are individual stars, and what percentage are actual galaxies.
Right. I think that's a fairly easy one, at least if you're in the northern hemisphere, even if you're in the southern hemisphere. Jason, you want to take that?
Go ahead.
Sure. Yeah, they're all stars in the Milky Way galaxy. Anything you can see with the naked eye. There are a couple examples of other galaxies, but they don't look like stars. They look like these fuzzy blobs.
Right.
So in the northern hemisphere, you can see the Great Galaxy in Andromeda, and from the southern hemisphere, with your naked eye, you can see the large and small Magellanic Clouds, and those are other galaxies near the Milky Way.
Yeah.
Nice.
So everything you see is a star.
Everything
is a star. It's like Hollywood, right? So and by the way, this is something I found interesting when I first learned about it. Most of those stars are what are called giant stars. They're really big, bright stars. Mm-hmm. You're not seeing the typical stars because they're too dim. Right. You're seeing the brightest ones, right? It's like looking at only the front row of your classroom. You're only seeing the brightest students, if that still works that way, right? Okay.
Very cool. All right. I want to read this question because it sounds like this person might have a little bit of an issue with you, Seth.
Not the first.
God, I'm going to find out who it is, but I lost the actual question. But here's what she wanted to know. Aren't we overstating the importance of intelligent life? I mean, isn't the idea just to find life? So is that an argument to be made? There is.
Actually, where I work at the SETI Institute, 95% of the scientists there are not looking for intelligent life. They're looking for life. And they're looking nearby where you can get some, immediate data by sending a rocket somewhere, Mars. But there's 6 other places besides Mars where there might be life, essentially next door. There are 3 moons of Jupiter. There are several moons of Saturn. These are all places where you might have some liquids. Right? In most cases, liquid water. And if you have liquids, then you get chemistry. And if you have chemistry, maybe you cook up something alive. So, yeah, if you want to find life, that's maybe the way to do it. And that's where all the big money is. That's what NASA's doing, right? But intelligent life, most people, if you say, hey, we're going to use your tax dollars to find pond scum on Mars. And they'll say, yeah, okay, that sounds okay. But if you say, how about looking for the kind of life that could hold up its side of the conversation? Intelligent life, I think they're more interested in that. That's my bias, but I think they're more interested because those are the kinds of aliens they see in the movies.
That's so true. There you go. Oh, that's excellent. Let's listen to Joe Cumming. He says, life as we know it is carbon-based with a lot of hydrogen, oxygen, and nitrogen mixed in. Is it possible that life could have a different elemental makeup in a world where other elements may be more suitable for reactions to that lead to life?
Sounds like a perfect question for our astrochemist Jason Wright.
Yes, Jason.
All right. Well, I'm a little weak on the astrochemistry, but yeah, absolutely. I mean, this goes back to science fiction. On Star Trek, they had the Horta, the silicon-based creature that they encountered. So we definitely try to keep an open mind about what life could be like, that it doesn't have to be carbon-based. Maybe it doesn't even have to be on the surface of a planet. I mean, there's old stories about, the dark cloud, the black cloud in space that is itself intelligent. So it's good to keep an open mind. On the other hand, we also have to tell the engineers that build our telescopes and instruments what it is we think we're looking for. And we can't just say, look for anything out of the ordinary. They need parameters. So we generally start with looking for carbon-based life. But it's true that, for instance, silicon is really common on a lot of planets. And so absolutely, we should think about that too.
Yeah, actually, Isaac Asimov, the famous writer, right, he was a chemist by training, and he actually wrote a paper in which he investigated what other elements in the periodic table, right, could form the basis for life, and silicon is the best, but really none of them work as well as carbon. The fact that we're carbon-based isn't so much an accident, I think.
Right, it's because it works, and most likely, I mean, nature does what works best, right?
Yeah, well, it'll do that sooner, and then as soon as you have one kind of life on a planet, probably it beats all comers.
There you go. All right, good question, though. Here's one from Gabrielle Keegan, who wants to know this. Gabrielle says, this is basically for you, Seth. What kind of signal is SETI searching for? So do you know what you're looking for when you're listening?
Well, we have to guess. I mean, it's very analogous to what we just heard about, how do you build a telescope to look for the signs of life. We look for simply a lot of energy at one spot on the radio dial. Okay, so it's what's called a narrowband signal. And all that means is It's a signal sort of like you would pick up on your car radio. You know, you're tuning the dial, trying to get that country and western station. I know that's what you listen to, Chuck.
You know it is.
Right. And you know, you just hear static, and then you hear squeal, and then there's the station. And it's the fact that station's at one spot on the dial, 8, 10 kilohertz, or whatever it is, that you know that's a transmitter. So we're not worried about whether they're sending us the value of pi or the Fibonacci series or prime numbers or any of the things that they do in the movies. We just want to find a signal that's at one spot on the dial. That turns out to be a lot easier than worrying about what the message may be. So that's what we look for. If you find that, you can be sure that somebody will have the capability of building a much bigger instrument and going back and saying, well, are they saying anything? Is there a message? That sort of thing.
Gotcha. So it really is just a signal.
Right. You just want to see the on-the-air sign is lit.
Exactly.
Yeah. Okay, well, listen, we've had these really excellent questions, but now it's time for the lightning round. It sounds dangerous. And
It sounds dangerous.
So lay it on us there, Chuck, and let's
Yeah, this is
really
where we'll move and try to answer as many questions as quickly as possible. And you will let us know when you are finished answering by hitting a little bell.
All right.
Right? Okay. So here we go. From Chaz Murray. Chaz Murray wants to know this, not necessarily about SETI or XOPs, but what is being done to detect and avoid incoming objects that could really hurt us? So does SETI do anything with that in terms of...
Yeah, we have some asteroid experts, so they worry about it. There are two problems. One, you got to find them, and if you find one that has your name on it, it's headed our way, you got to deflect it. And there has been research on both of these. I can tell you, if this will make you sleep better at night, that you don't have to worry about really big ones hitting. There's something that could take out, downtown Manhattan, but those we don't know about yet, but we're working on it.
Okay, all right. And no, I'm not going to sleep better. Sorry to let you know, that didn't comfort me at all.
Maybe medication.
Thinking of the destruction of downtown Manhattan.
All right.
And good night, Chuck. All right. Jason Watson wants to know this. Once you go alien, do you go back?
All right, that's good. I think I'll leave that for the other Jason. No.
Well, I do most of my research on stars and exoplanets and stuff, but I've started to do a lot of work with SETI and thinking about these projects. So, yeah, you could go back and work on the other stuff.
Okay, all right. Leon Gold from Twitter says this. How could we detect the presence of intelligent life on an exoplanet? So, it's.
Well, I would point one of Seth's radio telescopes at it and look for their signals. And I think earlier we talked about, you might find something weird in the atmosphere, like a chlorofluorocarbon that could only be created artificially.
Yeah, gotcha. That's the thing. I mean, maybe they'll send a rocket with their encyclopedia in it, and it just lands in a field somewhere. Doubtful, but.
All righty. Neil Califf from Twitter says this. 1 year on Proxima Centauri is 11 days. How could this impact our everyday lives if we lived on the planet?
Yeah, I'd get into the birthday candle business. All right, Jason,
this is a good question, because we didn't mention before that Proxima B is in the habitable zone. It's got the right distance to have liquid water, so this isn't a pure hypothetical. Maybe someday we'll be there. It means that the seasons only take 11 days to cycle through all of them. And in fact, it's so close, it could also mean that the star is what we call tidally locked, which means the sun never rises and the sun never sets. So that's a big deal. Either it's daytime or it's nighttime. There's just one time zone where you are, and the time never changes. Yeah,
that'd be easier for plants, wouldn't it? They don't have to rotate around to follow the sun. I mean, they can always be pointed in the same direction. Yeah? No?
Could be.
All right. Cool. That was so tentative. I know.
All right. Anything for Salinas. That's the actual handle. Anything for Salinas wants to know this. Is there an estimate on how old KIC 8462852 is, and how does a system's age affect SETI?
Yeah. Well,
all right. So the estimate for the age of that star is pretty poor. We know it's not super young. It's not like an infant star, and we know it's not about to blow up. But it's a couple billion years old.
Adolescent star.
That is what we can do. It could be youngish. It could be oldish. That kind of star is very hard to know.
It could be youngest, could be oldest.
oldest.
Like the parties you go to, right? Yeah. Okay, but at least a few billion years is long enough to cook up something interesting. I mean, it took 4 billion years to cook up Homo sapiens here, but maybe if a rocket wiped out the dinos 100 million years earlier, we would have had we'd have the cure for death by now. I don't know. Okay. Next question.
All right, here we go. Ben Harb. Ben Harb wants to know this. Do you think we will be able to mine resources from exoplanets in the future? I mean...
Yeah, the transport costs are going to be something. But, Jason,
I mean,
what do you think? Are you investing in this?
I mean, if we're... you got to get there first. That's the problem. But sure, you give us a million years. We've got settlements on those exoplanets. Yeah, they'll certainly have things to mine, and presumably we will have to mine them to build our settlements and our rocket ships and supercomputers and whatever else we're doing a million years from now.
Yeah, but we're going to mine stuff that's a lot closer to us much sooner,
I mean,
right?
We've got asteroids out there.
Yeah,
we've got asteroids in our solar system.
It'd probably be more feasible to mine an asteroid before we get to a planet that's
there are companies that are putting money into that. I mean, it's for real. I don't know if you want to sink your life savings into it, but you could. You could.
All right. I like this. Gaetano Marone. I think that's your name, Gaetano. I'm sorry. Gaetano Marone says this. Which conditions would create a stable or visibly non-spherical planet, such as a disk or a donut?
Yeah, donut planet.
Donut planet.
Yeah. So the thing with planets is the gravity is always going to pull them into a spherical shape.
Right.
And so if you want to get something that's not a sphere, you basically have to put it around it. So you could do one of these binary planets. You could have a ring of material like Saturn. But if you took the Earth and you made it into a donut, it would just squish itself back into a sphere under its own gravity.
Yeah. Well, of course, you could create an artificial planet, of course. If you're really an advanced society, sort of a super-duper space station, and then maybe the donut shape is not so crazy.
There you go.
Yeah.
I don't know why, but...
Make your eyes glaze over.
I'm very, very hungry.
Are you? All right. Another question in there real quickly.
Here we go. For humans, what is the biggest a habitable planet could be? Or really the smallest for us to be there?
Yeah, real quick.
So if you've got a planet like the Earth, it's going to be a little smaller than the Earth or a little bit bigger than the Earth. But if you get too much bigger, it's probably not made of rocks. It's probably made of gas and ice, and that wouldn't be very habitable.
All right.
Our planet is pretty much the size that we...
This is the size.
This is the size.
All right. Thanks so much to all of our wonderful listeners for those truly amazing questions. Unfortunately, we're out of time here on Star Talk All Stars. Thanks to Chuck Nice for